All right, for this video, we're going to be simplifying trig expressions. And to make your life easier when you do these, you're going to get this page out because it has all the different identities, trig identities, that we're going to learn about, or some that we already know, like we already know these ones. We already know that tan is sine over cos. So things like this, you should maybe already know that sine squared plus cos squared equals 1. So we're going to be using these to do our simplifying, okay? So when you simplify trig expressions, there are basically 2 steps that you do, and you just do them over and over and over again. So the first step is to make a substitution. And those substitutions always come off of this sheet. The second step is to simplify. And I'm going to say, this is what I call it, using legal math moves. So legal math moves are things that we have learned before in math. That might be if I add 2 fractions together, I need a common denominator. It could be if I have a fraction divided by another fraction, I should do keep it, change it, flip it. Okay, so there's all sorts of legal math moves. So typically I say start with a substitution and then do some simplifying. And then if you need to make another substitution, you can do that and then keep simplifying some more. And then maybe you make another substitution and then you simplify some more. Okay? So we're going to go back and forth between those. Now these problems are some of the more difficult things that we're going to do this unit, and the reason for that is that they are not repetitive. It's not the same process every single time. There's not something that I can tell you where this is the first step, this is the second step, this is the third step. Every problem is different. Every problem has to be thought through. You'll start to realize there are some strategies for doing these, but you can't consistently do them the exact same way every time. Okay, so the only way to get good at these is to practice them. That's it. If you don't do your homework, if you don't practice in class, you will not be able to do these. Okay, so we're just going to go through some examples. First, we're going to simplify 1 plus tan squared x divided by cosecant squared x. All right, so I'm going to go ahead and get my sheet out. Anytime I have a piece of a problem that has a squared in it, I'm going to focus over here on the Pythagorean identities because these are the only ones on the entire sheet that have squareds in them. So what I notice is that 1 plus tan squared equals secant squared. So I'm going to go ahead and put that on here. I'm going to replace the top with a secant squared, so I have secant squared x over cosecant squared x. And then after that, I'm going to see if I can simplify anything because I made my substitution, and I can't. I don't have anything on the top or bottom that can cancel. I can't square root this because then I'd have to square root something else to balance it out. So at this point, I'm looking to make another substitution. So the other substitution I'm going to make is that I know that secant is 1 over cos, and I know that cosecant is 1 over sine. So if I have secant squared, that would be 1 over cos squared, and cosecant squared would be 1 over sine squared. So I'm going to go ahead and make those substitutions. So I'm going to say that this is 1 over cos squared divided by 1 over sine squared. All right. Next, what I'm going to do is a legal math move. That means that when I have a fraction divided by a fraction, I know that I can do keep it, change it, flip it. So I'm going to go ahead and keep the first one, 1 over cos squared, change it to a multiplication problem, and flip the second one. So sine squared x over 1. I have another legal math move I can do, I know how to multiply fractions. I just go straight across. So 1 times sine squared is sine squared. Cos squared times 1 is cos squared. I don't have any more legal math moves I can make, so I'm going to go ahead and look at my sheet. When I look here, I know that sine over cos is tangent, so that means that sine squared over cos squared would be tan squared. So I'm going to substitute it. I'm going to say this is tan squared, and that's pretty simple there, so that means that I'm done. All right, let's try another one. So here, we're going to simplify, I guess I should have said that in the instructions. Simplify cos x minus cos cubed. So here, I don't really have any substitutions I can make. There's nowhere on my sheet that has a cos to the third. Cos could become 1 over secant. That doesn't feel like it's going to make anything better. So what I'm going to go ahead and do is I'm going to factor this. I see that there's a GCF of cos, so I'm going to say this is cos x, and that leaves me with 1 minus cos squared x. So if you guys recall, cos to the third x means that I have cos times cos times cos. It's the same thing as writing cos x to the third. So you're welcome to write it that way if that helps you think of it better. And at this point, I'm going to go ahead and look at my sheet. And I can see on here that 1 minus cos squared is the same thing as sine squared. So that means that I have cos x multiplied by sine squared x. And technically I don't need those parentheses. I can just write that as cos x sine squared x. And I'm going to say we're done because I know there's nothing else we can really do with this. I would call this simplified because we took something that was 2 terms and we brought it down to 1 term. Right? The nice thing about this assignment is that I am going to give you the final answers because the important part of this is the process. It's the individual steps that you do. The final answer is not necessarily what is the most important about these. So you'll kind of have an idea of like what you're trying to get to. Okay, here's another example. We're going to simplify sine x times tan x plus cotangent x. Now, after I've done a couple examples, this is about the time students start to get stressed out and they say, I could never do that on my own. And first of all, that's not true. You could, because I felt the same way when I first started learning these. At this point on the third example, the goal is not to do it yourself yet. The goal is for you to watch me do it and feel like you understand the steps that I took. I don't need you to see it ahead of me. I just want you to understand the steps that I'm taking. And then hopefully as we do more and more examples over this video and also in class, and when you do it on your own, you'll start to see, oh, hey, that's a strategy that I've seen Miss Rice use, and then you can use that yourself, okay? So what I'm going to do first is I'm going to go ahead and take tangent and cotangent, and I'm going to write both of those in terms of sine and cosine. So I'm going to leave this right here the same, and then I'm going to look at my sheet, and I know that tangent is sine over cos, and cotangent is cos over sine. So I'm going to make a substitution. And now what I need to do is some legal math moves. So I have one fraction plus another fraction. It will be beneficial for me to get a common denominator. So this denominator is cos, this denominator is sine. once I have a common denominator, I can add those fractions together. So I'm going to take this one and multiply it by sine on the top and the bottom. I'm going to take this one and multiply it by cos on the top and the bottom. And then I'm going to go ahead and simplify. So I still have, I switched to thetas when I should have kept all those as x's. Okay, so I still have the sine x in the front, and then inside I have sine squared x over cos x sine x plus cos squared x over cos x sine x, or sine x cos x. It doesn't matter which order you say it in. So that was my first legal math move, was getting that common denominator. Now I can go ahead and write this inside part as one fraction with that common denominator. Now at this point you could do a legal math move, so I can see that these signs could cancel out, or I could look and I could see if there's a substitution to be made. And here I'm going to go ahead and make the substitution because it's a quick one. So I have sine squared plus cos squared. Remember, anytime I see something squared, this is a good section to look at because it has all the squared stuff. And I can see that sine squared plus cos squared just equals 1. So I'm going to go ahead and make that substitution real quick. So this right here equals just 1. So I have sine x times 1 over cos x sine x. And now I can go ahead and do that legal math move of canceling. Sine divided by sine is 1, so those simplify. And then that gives me 1 over cos. And now I can look at my sheet and I can see that 1 over cos equals secant. And so in the end, I'm going to say that this expression right here simplifies to just be secant. Okay, and we're going to do one more example. All right, so we have sine x, the instructions are going to say to simplify. Sine x times cos x times tan x times secant x times cosecant x. And what I'm going to do is I'm going to leave the sine, the cos, and the tangent. And I'm going to use my sheet to make a substitution for the secant and the cosecant. So secant is 1 over cos, cosecant is 1 over sine. So I'm going to say this is times 1 over cos times 1 over sine. And what happens here is the cos and the 1 over cos are going to multiply to be 1. The sine and the 1 over sine are going to multiply to be 1. And so that expression simplifies to just be tan x. Okay, so when we are working on this for this unit, it's going to be really important that you have this sheet on you every day because it makes your life easier. Otherwise, you have to have them in your brain memorized. And it's also helpful to have some strategies. So here are the strategies that I thought up, but we're going to add some as we continue to do these. We'll be adding to this list, okay? So first, if a term is squared, look at the Pythagorean identities. So that's one of the things that I said a few times during the video. Next, if you are adding or subtracting two fractions, get a common denominator. If you are dividing two fractions, do keep, change, flip. One strategy that works, I would say probably 70% of the time, is to get everything in terms of sine and cos. The reason that that's a good strategy is because if you look on this sheet, there's sine and cos are like used over and over and over and over again. So sine and cos, if in the Pythagorean identity, sine and cos actually go back and forth between each other. With tangent, you have sine and cos. With cotangent, you have sine and cos. With cosecant, secant, you have sines and coses related there. If you look at these other funky formulas that we will learn later on in the unit, all of them have sines and coses in them. And so getting everything in terms of sine and cos is a good strategy because so many of the substitutions have them inside of it. The next one we're going to say is if the problem only has cotangent and tangent, then you should not, do not use sine and cosine. So usually students think about this and they say, okay, 100% of the time I'm going to turn this problem into sine and cos. And since it's only beneficial 70% of the time, then that means 30% of the time that student is very frustrated. So yes, turning everything into sine and cos is nice, but if we have a problem that maybe has tangent and cotangent, then we shouldn't do that. And the reason for that is because tangent and cotangent go back and forth. So maybe these would be a little bit easier to use, okay? So the purpose of these two, the thing that you want to think about with these two is you want to look for a relationship. And so what I mean here is like sine and cosecant have a direct relationship to each other. Tangent and cotangent have a direct relationship to each other. If we have a sine squared and a cos squared, those have a direct relationship to each other. If we have a tan squared and a secant squared, those two have a direct relationship. So what I mean by direct relationship is that there's some substitution on the sheet where they can go back and forth and replace each other. Okay, so as we continue to do this this week for a couple days, we're going to learn some more strategies and we'll keep coming back to these notes and adding those strategies down because this is the best thing we have to make these problems easier for ourselves.